try this through example. You can read those other slides about what modulus is. Modulus is the square root of x squared plus y squared. That's the modulus r. So if x is 3 and y is -4, all you do is you go the square root of 3 squared plus -4 squared. By the way, what is 9 plus 16? What's the square root of 25? There you go, 5. So this point, if you were to draw it, you go over 3, and then you go down 4 to get to here. How far is it from the origin to that point? 5, yep. Now what we might be interested in is what is the angle? What's the angle from here down? Well, we know that this is 4 and this is 3, so we call it the argument. That's going to be the arctangent of y over x. And that arctangent of y over x is going to be 4 over 3 arctan, or inverse tan, of 4 over 3. And could you get me in your calculator what that is in degrees to the nearest tenth? Yeah?
How do we know which side was the angle or finding?
Yeah, that is the toughest part of this whole unit. We're going to do that tomorrow. And I'll give you a little overview in just a moment. But did you, with your calculator, get me an angle? That's a really good question. Give it to me in the nearest tenth. I would guess it'll be over 650. 53. And it's negative 53.1. Now that's degrees. Do you know what that is in radians? Yeah, it's really close to 1. And you can do that in radians and get point, what was it, 93? Or you could do it the really easy way. Keep it in degrees because you understand what 53 degrees is. And then take the little degree symbol out and multiply by pi over 180. And that's going to get you that answer. But on paper, I think it's really helpful to have it like that. So my answer for this problem is z is 5 times the cosine of negative 53.1 degrees plus I times the sine of negative 53.1 degrees. That's kind of long, isn't it? Think, Liz, that's a little long. Yeah, let's shorten it up a little bit. Let's take these letters, C, I, and S, and say that it's cosine of this angle, I sine of this angle. We're going to shortcut it to the cis of negative 53.1. That means the same as that. Do you remember that? Yeah, good. Go to number part C here real quick. Now I wish you could do the same thing here, but we need to get it all in the numerator. We got to get this I out of here. So to get the I out of here, what do you multiply top and bottom by? 1 minus I. Good. So let's do it. So this is going to be 1 times 1 is 1. Negative I plus I is 0. Plus I squared. Whoops. Is that right? Is that right? 1. Oh, no, it's minus 2I. And then it's going to be minus I times minus I is going to be negative 1. All over, 1 times 1 is 1. Middle terms drop out. And then it's going to be minus I squared will be plus 1. So these will cancel. I get negative 2I over 2, which is what? 0 minus I. Does that help a little bit? Yeah. Yep. So x is equal to 0 and y is equal to -1. Now you should be able to find r and find theta. By the way, I draw a picture of that. 0, -1. What's this angle? Yeah, it's -pi/2. Good. So there, you don't even have to crank it out. And how far is it? If we're just going down here, -1, how far is that? It's 1. So the answer for z is z equals 1 times cis of -pi/2. Oh, that's so much fun. Yep. R times cis theta. Yep. So that's the answer for that one. And you're going to just keep doing that. Use these and figure that out. And then I just want to give you one more very helpful piece of information. So x plus I y can be converted into r cis theta. R times cis theta. And the reason that works is that x is r cosine theta and y is r sine theta. So when you put those together, square those, you're going to get x, this is r. You're going to get r squared, square root is r, and sine squared plus cosine squared is just 1, so this is going to be r. And this angle, inverse tangent of the r's cancel out, sine over cosine, that'll be theta. Here's the last thing I want to show you. Please write this down. Can you find this? The formula for finding angle is no problem, y over x, for all of these. Quadrant, anything in quadrant 1, like 2 plus 3i, or 5 minus 2i. These you just do inverse tangent y over x. Okay? But if you're in quadrant 2, we only go between pi and -pi by convention. You're going to take the inverse tangent of y over x, and you're going to add pi to get this one, and you're going to subtract pi to get this one. And that doesn't make a lot of sense right now. I'll prove it tomorrow, and we'll do a little bit more with it. But I just wanted to make sure that if you saw -3 plus 2i and you take the inverse tangent, you're not going to get this quadrant 4. You're going to add pi to get to quadrant 2. Or if you had -3 minus 5i, you know, you're going to get something in quadrant 1 because inverse tangent of a negative over negative is a positive. So you subtract pi to get down here. And we always stay between pi and -pi.